Welcome to In 5 Minutes. We now take problem on temperature stresses. Our problem statement is a 4-meter long steel bar of square cross section of 40 mm side is heated through 75 degrees centigrade with its ends clamped before heating. Ends are nothing but supports. Calculate the thrust exerted by the bar on the clamps for two cases. In the first case, if the clamps or supports do not yield. Second, if the clamp yields by 0.6 mm. Now they have given the property of steel as ES is 200 gigapascal and the linear coefficient of thermal expansion alpha as 11.5 into 10 to the power minus 6 per degree centigrade. Now we first draw the figure for the problem. So we have a steel bar of length 4 meter or 4000 mm whose sides are 40 mm as shown in a figure. So in this figure we show a square steel bar which is in between the two clamps, which is nothing but support. Now when this clamp is being heated by 75 degrees centigrade, that is delta D is 75 degrees centigrade. Now when this steel bar is being heated by 75 degrees centigrade, that is delta D is 75 degrees centigrade. As the clamps try to hinder the elongation, free expansion of the steel bar, there will be some temperature stresses and strain that will be developed. Now they have asked that in the first case, if the clamps do not yield, that is they are very rigid, what is the stress or of thrust exerted by the steel bar on the clamps? And in the second case, they have asked that is if the clamp yield by 0.6 mm. Now as we know, the expanding steel bar will try to impose some force on this clamp. So in the second case, they have asked when the force exerted by the steel bar on the clamp is such that the clamp yield by or moves or deform by 0.6 mm, what is the resulting stress in the steel bar? So this is a part 1 and this is a part 2. So we now start with the solution. Part 1, when clamps do not yield, that is the delta L of the structure is 0. So we have our compatibility equation as delta L is equal to 0. Let this be equation 1. Now we know the compatibility equation for temperature stresses are delta L is equal to free expansion plus expansion prevented. So we now put the values. Delta L is 0. Free expansion is given as alpha delta T into L plus expansion prevented will result in some kind of stresses in the steel bar and it is given by sigma L by A is nothing but PL by AE, where sigma is P by A. So now upon substituting the values, we get 0 is equal to 11.5 into 10 to the power minus 6 into delta T is plus 75 since it is being heated into length is L, which is not given, plus sigma, this is the stress which is being induced in the steel bar, multiplied by length upon E of steel bar or ES is 200 into 10 to the power 3. So L and L will get cancelled. We get the value of sigma in the steel bar as minus 172.5 Newton per mm square, and this stress will be a compressive stress. So as your steel bar is being heated by 75 degrees centigrade, it will try to expand. Now since your clamps are rigid, whole of the free expansion has been prevented, so the resulting stress in the steel bar will be equal to minus 172.5 Newton per mm square. Now in the second case, part 2, when the clamps yield by 0.6 mm, we have compatibility equation as delta L is equal to 0.6 mm. Now again we write the formula for delta L as free expansion plus expansion prevented. Upon substituting the values, we get now delta L is alpha delta T into L plus sigma L by E. Now upon substituting the value, we get 0.6 is equal to alpha is same 11.5 into 10 to the power minus 6 into delta T is 75 degrees centigrade plus 4000 mm plus sigma into length 4000 mm upon ES is 200 into 10 to the power 3. Now this is the stress induced when the clamp yields or extends by delta L is equal to 0.6 mm. So upon calculating, we get the value of sigma in the second case as sigma is minus 142.5 Newton per mm square. Of course, it is again compressive. Now we see that in the first case, the stress induced was minus 172.5 Newton per mm square Now in the second case, as your clamps has yielded little bit, the steel bar has been relieved and the resulting stress induced in the steel bar in the second case is lesser than the stress induced in the first case. So with this, our problem is solved.